Yes, that's great.
Now let me switch to presentation mode here. Hopefully it doesn't blink things up here. Okay. 1 second. No. Sorry. Oh. Do you guys see my screen?
Yes, looks good. Yes.
Awesome. Okay. All right. Yeah, this is a quick presentation to walk you through the Spirent solutions in the V2X technology, with a focus on the CV2X test solution, given that it's the it's in the main topic for the upcoming Plugfest, and this series of presentation are in that context. So I'll walk you through that presentation. So feel free at any time if you have any question to either just ask your question or put it in the chat, or contact me afterwards after the presentation if you have any further questions. Right, so the Spirent products for V2X are organized in 2 main families of products. So one, the one that is that we're using in the OmniAir context is dedicated to what we call conformance testing, and that solution applies for both DSRC and CV2X. And looking at the different regions, our solution covers all available test specs independent of the region. So we have the message dictionary and applications and all the different layers. In the next slides, I will go a bit deeper into which layers we cover and which are out of scope for our solution. But the solution is dedicated to covering all the different regions. So it includes the EU, CITS specification, the US wave, the also the EU for CV2X, wave for CV2X, and also the China specs are covered. Then we have a second family of products which are dedicated to functional and performance testing. And for that solution, we have DSRC coverage. CV2X coverage is something that we are targeting. We'll certainly have that in the coming months, I would say. Yeah. And so far, that solution has a message dictionary for the Etsy stack or specifications, and also for the US protocol stack. So I'll start with the conformance test solution. So this is a view of what a Spirent test system for V2X, CV2X will look like in general. So you will have our test platform called TT Workbench. It's an integrated development environment capable of supporting different types of protocol test scripts. So it allows automated execution of test cases and also analysis of test results. You have you can look into the message sequence between the test system and the DUT, and also look into the detail of the messages for analysis. So also part of the test system is a proxy radio that we use for accessing the RF. And that proxy radio can be either DSRC or LTEV. Displayed here is called a wireless unit, which we use pretty much as standard there, but the solution is agnostic to that. So you could pretty much take any piece of DSRC or LTV hardware there, as long as it implements the interface that we require there. So actually, for the US, there's a TCI, there's a proxy specification for that, which we support, and that's pretty much transparent, independent of the vendor. Also, depending on whether the DUT has radio capability or not, so you may have units for which the radio capability is not yet available, so we can also test directly to Ethernet. And as part of this test system, which is quite important, especially in the context of CV2X, we have a GNSS simulator that provides the timing and also can be used for simulating mobility. So I mentioned the common features. So these features are common across all Spirent test product for conformance testing in the V2X technology. So they are all based on the TT Workbench platform. So it's a standardized test notation with a very advanced tool set for test management, also automation. You can integrate it in your regression testing process. So having it being executed per command line and basically in the CI/CD environment, all the features that you would expect from an automated test tool. So as I mentioned, you have support for wireless mode, so to the RF using an external hardware device for the radio, or you could also test directly. Several of our customers also use that feature, actually sending the DSRC packets directly over UDP Ethernet to the DUT without, if they're not interested in testing the RF, so to say implicitly. All of those test suites support automation using an output tester or TCI application. We have also a set of functionalities for enabling customized test cases. So we can integrate a dedicated message set, or also provide the source codes for all the test scripts, which allow any of our customers to make adjustments to the test suite or create new test cases as per their requirements. So, and the test suite is the test product are all aligned to standard test specs. We are qualified test tool for DSRC per OmniAir, and we're in the process of completing qualification process for CV2X. Same, we are aligned with the ETSI test specs and also with the China Communication Standard Association test specs. So, looking at the conformance testing situation, solution for WAVE. So this solution is valid for DSRC and also for LTV, although they are licensed differently. So they are different licenses, but it's all the same environment, same look and feel. And you have support there for .3, .2, .4, as long as DSRC is concerned, and also for 2945. A bit more detail on that, looking at it graphically. So you have here on the left-hand side the DSRC protocol stack illustrating our coverage. What you can see here is that we don't cover the lower MAC and the file layer. That's simply not our area of expertise. But as I mentioned, we can work with pretty much any device or test tool vendor providing an interface that allow the transmission and reception of messages through those layers. So our focus is on the 1609.4 for the SRC, .3 and 2945, as well as .2. Same with CV2X, at least in the US wave context. This is an illustration of it. So you have the TT Workbench test system here on the left-hand side, and we can emulate any of those protocol stack layers that we support. So we can create messages as per all these standards. We can transmit those either directly, as I mentioned, or through the RF. We can decode and analyze all messages that we receive, and we have a mechanism for validating the requirements as per the test specs automatically. So it's a push button solution. So you will have the possibility to load a set of test cases, do, let's say, the basic configuration, for example, which IP address the proxy modem use, any radio parameters, for example, and then you can run your test cases, and at the end you get a set of verdicts and also a deep analysis of where test cases fail, the reasons why they fail, and so on. So it's very much automated system. We have, as I mentioned, the same configuration for DSRC, right? But technically, conceptually, it's the same. So I will not go too much into the detail for that. And if we look at it beyond the US protocol stack, which is the focus for OmniAir, we also have coverage for the China protocol stack. Pretty much similar architecture here with support for DSMP, for the message dictionary, as well as for the application layer. A more detailed look into the test cases. So this is just for reference. So it's approximately some 250 test cases that are supported there across the different protocol layers for DSRC. And obviously for CV2X it's a bit less because you don't have the wave, the .4 test cases, and some of the DSRC radio specific test cases will not apply. But for 2945, it's almost the same number of test cases, and pretty much the same for .3 and .2. So for this is a more detailed look at it, at the different standards that we support there. Well, the US, the China IMT 2020 stack, and also the EU CITS protocol stack. I will not go too much into detail here. So this is a bit of a look and feel of the application. So you have the test scripts listed here. Here, this is, for example, after test execution, right? You see the green, the test cases marked as green are passed. So those gray here are not yet executed. And you also have here the parameters, right, for the test cases. This is the detailed view I was mentioning, showing you the the difference between data that is received and the expectation. So here you can see on the left-hand side the expected data, and on the right-hand side what is actually received. Also here you see the message sequence between the test system and the DUT. So you have the possibility to look at every part of that message sequence. When you get a verdict, for example, the pass verdict, it will show you why. And also when you get a fail verdict, it will give you an indication of why. So a lot of possibilities for failure analysis. And also here you can see the script, right? The source code for the script. So you can modify and just run the test cases, create new test cases for your requirements. We have the same type of test package for different regions, as I mentioned. But for the sake of time, I will not go too much into those details. So feel free to reach out to me if you want a more detailed view on this. So it's basically supporting the EU ITS protocol stack with all the protocols that are available there. It's also, as I mentioned, same principle. You have the OTT Workbench environment, you load your test suite, you have the same look and feel, and you can execute your test cases. Very straightforward. Technically, similar architecture, so you can even reuse the DSRC or C2X hardware that you have there in place. And also the GNSS simulator is used in the same manner in that context. So I will not dive into the details of the different protocols there for the EU. Just to mention that for the China protocol stack, these are the list of standards that we support. I understand that this presentation will be made available, right? So feel free to reach out to us if you have any specific requirement that you would like us to look into. And we'll be very keen to find a solution for you on that. That will close my presentation on the conformance test part. So I will now walk you through our solution for functional and performance testing, which is also a bench test solution, but provides some features that will help you reducing, or let's say controlling your cost on field testing. So the purpose of it is to support functional testing, so allowing you to validate the behavior of an OBU or a roadside unit in a bench context by simulating the environment, so simulating the traffic and observing the behavior of the DUT while that simulation is ongoing. So, and you have the possibility of benchmarking the device. You can also measure some metrics like latency, time to event. It also enables you to test the robustness by increasing, for example, the number of devices in a given environment, and pretty much scaling the simulation and verifying, allowing you to verify how the DUT reacts to that scale. So it's a modular solution, so allowing you to test from an early stage while you only have a solution, a software in your loop. So it can be a software or a model, like a simulate model. So you can connect directly to the test tool and test your system against that. And then you can integrate, for example, a canvas simulator to observe the behavior of the DUT on the in reaction to V2X messages or to a specific V2X solution situation. For example, in an intersection collision warning situation, that's a vehicle actually detects intersection collision warning, and as a reaction will trigger brake on the device. You also can scale this solution up by adding a GNSS simulator that will enable you to do some more accurate mobility simulation, and also provide the timing and positioning for both the device on the test and the test system. And then finally, you can also have a channel emulator on the RF communication, allowing you to verify that in spite of channel impairments on RF impairments on the radio, your applications are still capable of performing as per your requirement. Right? So, for example, detecting a particular situation, emergency situation, or, for example, identifying a vehicle despite, let's say, poor visibility on the RF. So these are the different levels of scalability of this solution. And to close the presentation, a bit of look and feel of how the application looks like. So you have, it runs on different, you can run on different mapping material. It can be open source, OpenStreetMap, it can be Google, or here, for example. And you have the possibility there to load predefined test scenarios or define scenarios by yourself and on your own, and then or even modify the predefined scenarios that are provided. So we offer this solution in different packages. So a basic, advanced, and premium package, depending on whether it will include the GNSS simulator, for example, or whether it will include automated feeding models. So depending on your requirement, we will work with you to identify which of these configurations work best for your needs, and then help you get that up and running for your system. A set of solutions of applications that are already supported with that solution. So these are ready-to-use applications that you can just load and run against your system, and then you will be able to validate whether your system is reacting as per your requirement while those scenarios are executing. So as you can see, there are vehicle-to-vehicle applications, but there are also vehicle-to-infrastructure applications. For example, if you want to test an RSU or test how an onboard unit will react to a RSU broadcasting. So quick overview of the different standard specs that are supported with our solutions. This is just for reference, and a bit of outlook of how this solution looks for cellular V2X. But as I said, this is not yet in place, and is something that we'll probably provide in the coming months. Summary of the features. So as you have seen, our solutions provide a unified test platform independently of the PHY technology, whether it's the Wave DSRC, whether it's the EU or cellular V2X. Our solution is agnostic to that. So we have the possibility of testing on-board units as well as roadside units. So the solution is extensible, and as you can modify the test scripts, you have the possibility to simulate timing and mobility. So you have full control of the timing and positioning, rather than depending on the live GPS, for example. And you have a high level of automation to command line and also test control interface and upper tester. With that, I will thank you and ask if there's any question.
Thank you, Dr. Bucher. That was an excellent presentation. I would just encourage people to put questions in the chat box or go ahead and speak up. Jim, did I hear you speak up?
Not me.
Okay.
Great. Thanks, Elaine.